Hey guys, welcome to DevOpsSchool. Kubernetes is one of the most popular technology in cloud computing as of today. Learning Kubernetes is essential for any DevOps professional, and one of the most in-demand certification is Kubernetes Administration. In this session and in this series, we are going to learn various aspects of Kubernetes Administration, which will help you to prepare for the Certified Kubernetes Administration exam or CKA exam. This series is divided into 20 parts, therefore subscribe to our channel and follow the playlist for complete understanding.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOpsSchool certification level courses, which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai, and in Pune. Simply compare our many courses, find the one that suits your style and schedule best, and start today.
Okay guys, so let's get started. So I think in the last session, what we learned, we have discussed about what is Kubernetes and why Kubernetes. And today I'm going to discuss about Kubernetes architecture in simple way, how Kubernetes can bring health to you, how Kubernetes can bring wealth for the organization, and how Kubernetes can bring happiness for everyone. So basically the answer is hidden in Kubernetes architecture. Okay, so now let's get started. So as part of this discussion, I'm going to teach you the masters, node, pod, services, deployments. So these are the things which I'm going to cover. So now let's understand that Kubernetes big picture view. Now look at this here. We say Kubernetes is an orchestrator for microservices apps. Okay, so in the last statement I said Kubernetes is an orchestrator for containers. Now I am saying Kubernetes is an orchestrator for microservices apps also. Now what is a microservices? I believe all of you know that microservices. So nowadays, earlier we had a software development which was in, let's say, monolithic, then we got into the SOA, then now we are in microservices, and we all are developing a software now in the today's world in terms of microservices. One of the things which we have problem with the microservices is like this. Earlier we used to have all the software in one bundle. Now it's distributed. That means, let's say if you have one product, you may have 200 microservices only for one product. Now why we have a 200 microservices, that's a different question, but that's the reality, right? In a real world, if you have one application which is serving your request and response, okay, maybe Flipkart, maybe Amazon, maybe Facebook.com, maybe Twitter, maybe LinkedIn, or maybe any application which you're using, it's based on the microservices. Now the question is, they are not one system, they are more than 200 or 300 components, small component, small microservices are attached together and serving your request and response. Now the question is, once you have 200 microservices, who will manage it? That's the question. Who will manage it? Who will give the guidance? Think about it. Visualize the problem in your mind. They are not a one software right now. Or let's say later on we got into the SOA, service oriented architecture, then we started calling web server, app server, database server, something like that is not anymore. Right now we have a microservices, so not 1 2 3 4 5 6, 200 plus. So now how would you manage those number of microservices? How can you orchestrate those? How can we control those microservices? So Kubernetes can help you. How? Let's try to understand this. This is a football ground. Look at it here. And we have a team and we have a manager also. We can call it coach. Okay. We have a team, we have a manager, right? And now, so what do you think? What should be the goal for each team? So we have a good team, right? So what should be the goal for each team on the ground? What should be each team members on the ground? What do you think? Any idea? Any comments?
Sorry,
You
repeat
know?
your question, Rajesh.
Yeah. So I'm asking, there is a soccer ground and there are teams, there are a manager. Okay. So what should be the goal? What should be the goal for it?
Every player should play his responsible, like a forwarder, okay, middle,
Right,
like
right. You answer correctly. But many people say, okay, the each team players, the objective is to make a goal. If there is a make a goal, then you all will be near to goal post. Like we used to play in our childhood, right? We used to go to the near to goal post and shout on other people. Okay, give me the ball, I'll make a goal and something like that. This is not the way it's going to work out, right? So this is not the way you are going to win the game. Okay, so here every top team which you look at it in the world, they are not playing for winning the game. They are not playing for the winning the game. Okay, they are playing with the best coordination, and those who play, those who coordinate well, even though if you are smallest team, well known, less known team, you can win, because if you coordinate well, you will win. Okay, so that's a goal. So here, who can help all these players to coordinate? Who can help all these players? That is where the manager comes, right? Manager is needed, coach is needed, master is needed. Who can say to the players, okay, do what I say. If you do not obey me, I will take you out of the ground. Okay, so everyone has to hear the manager and coach, and once everyone start hearing the manager and coach, the scenario is like this. Why? Because everyone, understand this, everyone is following manager. If someone is not following manager and coach, then manager will throw him out of the ground. Okay, now manager knows, understand this, manager knows each and everyone's capabilities, and as per their capability, manager coach places at the respective places. So someone is at the attack, someone is at the defense, someone is in between coordinating and all. So now you see here, these people have the control. Who's controlling it? Manager. And what these people will do, these people, so if I put it up in this, let me try to draw a picture. So this is a game. Okay, now see here, this guy will communicate to 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 this guy will, so like this is a relationship. See here, the objective of this game is not to run. Players should not run, because the moment you run more, you get tired, right? The ball should run. So the team who's winning this match, those who's coordinating well, right? Because if you run less, you get tired less. You have a more energy to make a goal and coordinate well. So this is something like a game in the soccer game, and we have a master who controls everything. So now look at this here. In the if you look at the infrastructure also, production infrastructure, remember I said earlier only, we are in a cattle business. Do not talk about the pets business. Okay, so we are in a production, and in a production, if you look at this, there are different kind of microservices running. Some of them are HTTPS, some of them are search, some of them are auth, some of them are MySQL, some of them are KB store, some of them are log, some of them are load balancer. Various roles and responsibility, different kind of microservices will be there. Now who will control it? Kubernetes. You look at this here. Now how this each microservice is communicating with each other. So load balancer only can talk to HTTP. Now HTTP auth, search, and you see that the relationship. But the question is, who's controlling all this relationship? Who should talk to which one? So here in the last session, in the football ground, who was controlling? Who's supposed to talk to which one? Manager, coach. So here also there should be some guidance also. Guidance should be given. So the control of these microservices should be there, because if these microservices will not communicate in a certain ways, then your request and response will not serve. Remember, once you make a request, you don't know. Let's say if you log into the facebook.com, you don't know how many of services got involved in it. Maybe multiple, right? Once you click on the dashboard, pages, groups, this, that, how many services are involved in it, you don't know. So who's talking to which one? Who will decide? who will be the orchestrator of the microservices. And they're not 1, 2, 5, 10, 20. There are more than 200 microservices. Who will control that? So Kubernetes will control that. Kubernetes is your master. Kubernetes is a coach. Kubernetes is your manager who will control the behavior of all these microservices, whom should communicate with whom. Now, see the interesting thing here. These microservices, see, one microservices, look at the HTTPS microservices. You have in the node 1 and another one is the node 2, but still the behavior is same. Behavior is same. Again, HTTP is talking to auth or search. Other HTTP is also talking to the auth or search. And see here, first HTTP is in node 1 and second HTTP in node 2. No matter where the instance are running, the behavior is same. Who's controlling this stuff? Who's controlling this behavior and the cluster? Kubernetes. So that's the reason we say Kubernetes is an orchestrator of microservices. Okay, so microservices is a very interesting topic. Okay, so this is the something which you all must know: the concept of microservices, principle of microservices, design principle of microservices, how those microservices can be developed, how microservices can be communicate, set up the whole infrastructure and all. So you should know actually, because that's the reality of this day. This is how the software development will take place in today's world. Okay, so that's the one thing. But the question is, who will orchestrate? In this today's session, we are talking about the Kubernetes. Who will orchestrate? Kubernetes. Okay, so now as part of the Kubernetes, here you have an architecture. Look at this here very carefully. Here you have a master, multiple master, manager, coach. Let's say if one, see who controls everything? Master, manager, coach. If one manager will be unavailable, what will happen to all the players? That's not good, right? That's not good. Someone should be needed all the time, right, to manage all the players, all the microservices. So yes, you can have a HA, high availability. If one master is not working, other masters may come, and we will talk about the HA of the master at the end of this session, not now. This is the last session, I guess. Okay, so now yes, in a cluster of Kubernetes, you have a master and you have a multiple nodes all together, master and plus node forming together, and we call it KX cluster, Kubernetes cluster. Okay, now master control node. Who control master? Package, which you can see on the image. There is one package. Now the question is, who's writing this package? We write a package. Remember, we have only one job in Kubernetes, to write that package. The rest of the things master will take care of it. Okay, so look at this. Master is in charge, node is doing the work, what is instructed by master. If one node is not following, remember the same game, if one player is not following the instruction of coach, he will throw him out of the cluster, I mean from the ground. So same way, if any node will not listen to the master, master will throw that node out of the cluster. That's a rule. Okay, so this is the power of master, manager, coach in Kubernetes. So in Kubernetes cluster, you have master plus node. Okay, now look at this here. Here I see a little bit of different images. What is that? So here I know that master, which control the node, and you may have a multiple node. Everyone, a node who will do the real work, and master is in charge. Okay, now node has something like a pod. What is a pod? I don't know. We will come to know in upcoming session, but hold this question. Pod, what is a pod? I don't know, but one thing is I know, inside a pod you have a container. You see the image of containers image, right? That container is inside a pod. So that I know, I got to know. Okay, in a Kubernetes cluster there is a master. Okay, good. In the Kubernetes cluster there is a node. That's also good. In the node we have a pod. I don't know, but I'll get to know. But inside a pod we have a container, which we know very well. And let me tell you, if you don't know containers, if you don't know Docker, then you should not be in this class at all. Let me tell you very straightforward. You should be pro in containers. You should know what is a containers, how containers is being created. Then only you can understand the pod. Okay, so that is a different topic. So you must know. Okay, so yes, this I know that. Okay, so this is the architecture of Kubernetes. So now let's deep dive into that. Now I want to know what you have in the master. How this master, think about it, have a question mark in your mind. How this master control entire node, how this master manage the entire cluster, how this master manage the services behavior also. Microservices, remember, orchestrator. Kubernetes is an orchestrator of the microservices. So how that is happening, how that is happening. So we need to know the property of it, right? Master is so important component. Without master, nothing works in the Kubernetes cluster. So we should spend some time understanding about this. So let's get into this. Masters. Sometimes we call it masters. Sometimes you call it the Kubernetes control plane. It's not a panel. Okay, it's a plane. We call it control plane. So what is a master? So master you have to have in Linux. Okay, node for this year I can say node, it can be Windows as well as Linux. Okay, up to the last year it was not possible, but to this year onwards it is possible. So yes, you can say master has to be in a Linux 64-bit, node is in a Linux, we will use the Linux itself. Okay, not Windows, but yes, you can have a Windows from this year also. So yes, master manages nodes, that is sure, but master manages multiple nodes. You see dot dot dot, that means as many nodes a master can manage. That's a thing. Now master has a 4 component. I see that here four images are there, and there's a arrow is also is there which communicate to which one. What is this 4? So I know that master is in Linux, I know master is in 64-bit. Master has a 4 important component, and we need to know this important component. Look at this here. And one more thing I would like to notice this image. You see the right side, there is one icon which is getting duplicated multiple, four times. So first the bottom one, and then top one, and the extreme left one is only one copy, but the right side what you see, it's duplicated. What is that? Why this is duplicated? So let's deep dive into this. So master has 4 component. Master can be HA means multiple master is possible, because one master is down, then what will happen to my cluster? That will be a problem for everyone, right? So you cannot run production like that. So yes, master, you have a HA concept also, and yes, that is possible. Now master manages the nodes. Master has a 4 component. Master manages the nodes. Nodes can be in a Linux 64-bit. Master has to be Linux 64-bit. Node has a pod. You see here, look at this images very carefully. Node has a pod, pod has a container. Now let's increase one more thing. Pod may have a multiple container. In the extreme left side top one, you see here a pod, you have a 2 container. So other nodes you have a pod 1 containers, and pod 2 containers. So right now I got to know, okay, fine, in the Kubernetes cluster we have a master, we have a worker or node. Okay, master and worker both has to be in Linux 64-bit, but in this year onwards Windows is also supported for the worker or node. Node has a pod, pod has a container, pod may have a multiple container. So far I am okay, so far I got to know, so far I learned it. Now let's deep dive into the master, the most important component what we have. Okay, this is, we call it API server. See here guys, you have a 2 word, API and server. So what is the server mean? What is the meaning of server? Okay, what is the meaning of API? So first let's find it out, what is the meaning of API and the server. So I'll go to the Google here, API. What is API? So here can I see some good image? See here, this is a good image, right? Probably. Let's try to understand this. Okay, so what is API? So here I see there's a there's a lots of features are there, and all these features communicate through APIs. So API is something like a kind of interface from the one service to another service. We call it application programming interface. Okay, so here you have a one API, here you have a one API, like that, correct? Now APIs. So if you want to connect, let's say here, if I say, look at this here, car, if you want to travel from the car to sensor, okay, so you have to travel through API. Let's try to some different image also. See here, do we have images? This is the same image. Okay, so like that. So now what is API? So think about it. MS Paint. First understand the API. Okay, API. What is API? So here there is one feature. Okay, think about it. There is one feature. This feature. There's one more feature, and there's one more feature. There's one more feature. Okay, so multiple features are there. Now, if you want to think about it, if you want to access this feature, then you have to process through API. This is the API. Okay, so you have to connect. So this guy wants to connect to this one, so they will connect to API, and from here it will get into the system. There's also API, there's also API, there's also API, and here if you want to go from here to here, you have to travel through API. So API is like a programming interface. That means it is an interface between you and the service, you and the feature which you want to avail. That's called API. Now here is a server. So what is an API server? So here when I say API server, that means, see here, this is a one feature, this is a one feature, this is a one feature, this is 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 one feature. All these feature I will put it up, all the APIs you have in this place. Now you have one API, 2 API, 3 API, 20 API, 30 API, 50 API. See here, API 1, 2, 3, 4, 5, 6. So now what is this? Earlier we had one API. Now you have a multiple APIs together. Now if you want to connect from, you are the human being or someone, and you want to reach to this one, so you have to, let's say, reach here, and it will redirect to here. You want to reach to here, so you have to connect to this one and this one. So now who is processing? All this request is processing from the one place. Okay, so that is called API server. Think about it. There's a two word, API server. So in this component, actually you will find hell lot of APIs. That's the reason we call it server. We don't call it API. We call it API server. Okay, so now in our official keywords, what we have? So basically it's a front end to the control panel. That means any feature which you want to use it of the cluster. Again, I'm repeating. Please read my statement. Any feature you want to avail in the Kubernetes cluster, you have to go through this front end to the control plane. Again, how can you request to this API server? Through API, REST API. Okay, RESTful APIs. Now, what it consume, in what format the data it consume? JSON. Okay, so this is a API server. Again, here only you get all of the feature. You want to know 2 feature or 20 feature or 200 features. Every features, if you want to consume from the Kubernetes cluster, you have to talk to this. Without talking to this, you will not be able to communicate with it. Are you getting my points?
Yes, Rajesh.
Okay, so now what is the next component? Let's talk about it. Here we have
Rajesh,
a
here is a quick question. You just gave an example of a human being wants to access some services or features. So they have to talk to the API server, and the API will find out its relevant API, and then it will make the communication possible. But my question is how to talk. My question is how to talk to API server itself.
See here, one feature If they wants to communicate with another microservices, they, in that case also, they need to communicate with API server. So here in a nutshell, if I tell you, this is a good question, any external communication to the Kubernetes cluster or any internal communication to the Kubernetes cluster, that all requests will be served by API server. This is the front end to the control plane, and he is the basically manager, coach, master. Okay, so this is the guy, without that nothing passes. Okay, so you can say it's like a Chinese president. You can call this guy as a Chinese president. Nothing goes without his information, and he control the China and he control the world. Simple, right?
Yeah, no, that's all right. So how to talk to the Chinese president? That's my question. How to access the API server?
So how to access the API server? So you have one endpoint. Endpoint consists of IP address and some port number, and that you have to force the data into the JSON format. You see here, JSON format. So you have to write the JSON file and you have to send it to the API's endpoint. If you have access, authorized access, then they will accept that request. After that, the story is still pending.
So will this JSON file be a part of the package you were talking about?
Yes. This is the package which I was talking about here. This is the one.
All right. Okay. Now it makes it clear. Okay. Thank you.
Yeah. So here, now let's talk about the second thing. So here it's an API server. Remember, it's a two component API server of multiple APIs. Okay. Now next one is a cluster store. What is a cluster store? See here, guys. API server only can receive or send request. It cannot store it. There is no persistent storage. It cannot store it. It just can pass it. So where the storage will happen? So here storage happen in the cluster store. Now cluster store is another application or component which is running in the master, which is basically storing all the cluster state and configuration file, everything. In a simple way, if in the cluster store that data is not there, that means it's not exist in the cluster itself. Okay, so now cluster store is the persistent storage. It stored the cluster state and configuration. Now let me tell you here, this cluster store is powered by etcd. Yes, etcd. It's a key and values based, NoSQL based database. It is a distributed, consistent, watchable. Now let me tell you here, I'm not confusing it too much, but etcd itself is a huge topic actually. etcd. Okay, so if you have a questions, please come to this place and go to some images, and here you see etcd clustering, it's there, and all stuff like that. So you can read about this, what is the etcd, and it's an open source product. Okay, it's freely available. Many products, many components uses etcd. See here, simple, secure, fast, reliable, distributed. So easy. It's written in Golang. Okay, now let me tell you here, this is a distributed. I don't know how many of you understand the distributed. That means if you think cluster storage is just one application, I mean one storage, no. This cluster store itself is a cluster which has a replicas and shards. Now I don't want to get into that, but for time being, let's keep it simple. Cluster stored is a persistent storage, store the cluster state and configuration file, powered by etcd. etcd is a distributed, consistent, watchable, and it is a source of truth for the cluster. That means if anything is there in the cluster store, that means it's there in the cluster. If it's not there in the cluster store, that means it's never existed in the cluster, like that. Okay, now
so
you need to have
can we say, Rajesh, this is a soft database which works on key value pairs?
Yeah, it's a storage, but stored in the key values pair. Yeah, it's a storage.
So like Rajesh, like it's in a meta store, right? So information of the cluster.
Yes, meta information. Okay, it's not RDBMS. Okay, and let me tell you here, you have to have a backup plan for it. Okay, now before me talking about third component, let me play a game. Okay, So I need someone. So let's take it, human face. Human face. Here. So let's take, just a second. Okay, let's take this image. And here I am going to see here. So consider this human is a master, aka control plane, okay, aka manager, aka coach. So now if you want to send some knowledge, some information to this human lady, now where it will go? It will go and process here, correct? It receive here. Now this place you have no storage capability, correct now? So now this will travel to the memory, correct? Correct? Think about it. So here this is your API server and this is your cluster store. See here, this lady, let's say if I wiped out her memory, then this lady itself is not exist. Getting my points? Okay, so if you want to understand the properties of her, then this memory should be there. Okay, so API server just receive all the information, okay, all the information and store in the memory. Okay, memory. Okay, now let's talk about the third component, controller manager. Understand that. Read the every keywords very carefully. Don't rush. Don't try to finish the course in 1 hour or 2 hours, else you'll keep struggling for years and years. Okay, so understand, it has a controller and it has a manager. Two keywords are there. What is a controller? So controller means it controls something. What is the meaning of manager? So manager means this component manages multiple controller. That's the reason we call it controller manager. So here Kube controller manager manage multiple controller. And controller, what is a controller? Controllers control something. Okay, so this component we call it controller managers. Now here there are so many controllers are there: node controller, endpoint controller, namespace controller, and many more controllers are there. Now what is the job of the controller? So controller's job is to keep asking some information to the certain endpoints, and this will never be ending request. That means, let's say if I'm a controller, I'm not a controller manager. Remember, don't get misunderstood. Image, it has a controller, but I am talking about the controller manager. Understand that. So what is the job of the controller? Let's say I'm a controller, okay, and I'm asking Kamran, I need one information from you, only one information. Okay, what is your age? What is your age? What is your age? What is your age? I'm running in the loop and I'm keep asking it. So you keep telling me 30, 30, 30, 29, 31, 34. So you keep telling me something, but I keep asking you. So what I am, I'm a controller. I am asking you this information all the time, and you will have to respond me. Let me tell you here, if you do not respond me by mistake also, I'll throw you out of the cluster. Okay, so controller control one thing. Give what is your CPU? What is your CPU? What is your CPU? What is your node? What is your node? What is your node? How many pods are there? How many pods are there? How many pods are there? What is your number of pod? Which kind of pod you have there? So different kind of controllers are there. Okay, so controller manager has a multiple controller, and each controller control one thing, like a node controller, like a endpoint controller, like a namespace controller. So what exactly it is doing? So controller watches for changes. See here, and I think there's some background noise which I'm getting from somewhere. Okay, so what is the controller manager is doing? Controller manager watches for changes. See, watches for changes, that means, see here, watches for changes, that means, see, Chinese presidents need their army to watch, to control that everything's in their country, right, and the world. If let's say army is not informing me every minute, every hour, every day about the status of what is happening, then how this Chinese president will control the China and world, right? Correct. So it's like this, watches for the changes. So there's a controller, there is an agent, will keep asking what you are, what you are, what you have, what you have, what is your status, what is your status, keep giving me. The moment you don't give this information, you are dead. You are dead for the cluster. You are dead. Okay, so you are existed, never existed at all for the cluster if you don't give this information. So yes, controller manager manages a multiple controller. Controllers such as node controller, no endpoint controller, namespace controller, and there's so many controllers are there. What it is doing, watches for the changes, and so helps maintaining desired state. What is the desired state? I'll come back to this. This is a very interesting topic, but understand that controller manager will help you to manage the maintain the desired state. Desired state of what? Human being. Okay, so this is the third component of the master. Now let's understand this. Who's a controller manager in this phase? Who's a controller manager?
Is it your brain?
No, controller manager. Brain is your storage, right? See, this is the, how can you miss this so beautiful eyes, Kamran? It's not good, right?
I can't, mate. I can't. You're right.
Yeah. So see, these eyes are controller manager, acting like a control manager. Like that means, if let's say if I see you, think about it. Simple. Think simple. If I see you and you see me, that means you are alive. If I see you and you don't see me, you are dead. For me, completely dead for my cluster. It's like this. So you keep talking to me and keep giving me the information. What? CPU, RAM, storage, number of pod. Are you alive? Are you alive? Are you alive? Are you available? Are you available? Everything, node controller, node namespace controller, endpoint controller, so many things which keep these eyes keep asking you, each and every one in any room. Let's say there's a room and all of we are sitting, and this guy is asking, this girl is asking through her own eyes actually. So controlling everything, but not doing anything, just controlling anything. Just controlling means getting the information. Are you getting it?
So yeah. So when we actually like poll for some information in the shell, so the controller gives the information, or who gives the information? Is it from the master?
You won't get information. You won't get information.
No,
You don't do anything.
information. No, information on how many, how many nodes are there, or how many parts are now running. So this information is given by the controller?
Yes. Controller,
And
different.
basically, it does the polling then.
Yeah,
Keeps
interval.
doing it.
Yeah.
Okay.
See here.
Okay.
See, look at this here. Controller runs in the loop, never ending. If the controller dies, then your cluster is dead actually.
And can I introduce my own custom controller as well? That is possible.
I think there's huge noise is coming from your side. I don't know why. Yep, thank you. I don't know what is the reason, but am I the only one who's getting the noise from the Barun, or you guys are also listening, hearing?
No, there is too much noise when he speaks.
Yeah.
So I think you can put the question in the chat window. I will answer that in that case. Varun?
Okay.
Okay, so now guys, yes, controller runs in the loop actually, never end it. So that's a third component which we have understood, and understand that is a controller manager. So manager. Now fourth one, this is scheduler. As name suggests, what is it can do is schedule the work actually. See here, scheduler is a kind of one of the component in the master control plane. Watches API server. Think about it. It keep watching API server for new pod. Assign work to the node. Who's assigning the work to the node? Scheduler. It has affinity and T-affinity. Constraints also are resources also. I'm not confusing with the too many contents right now, but here understand that. See here. Let's say, where is the lady? Here. So now see here. You got the instruction here, stored here, and process here. This guy is reporting again and updating this one. Okay, and then scheduler, your mouth is like a scheduler. Now you will see and you will ask something. You will not do anything. You will ask something. You will ask something to do what? Your slave, your worker, your node. Do this. I want you to do this. So this is your scheduler. Scheduler watches API server always, because API server is the only front end what we have in the entire cluster. Remember, look at the arrow. When you get a request to the API server, it's stored in the cluster store. Controllers keep running in the loop and inform the API server. Scheduler also watches API server only to get a request. So basically here, any request which comes from the API server, scheduler go and do the changes in the assign the work. Assigning, not doing. Understand that. Assigning work to the node, and it has affinity and anti-affinity and all. So all these things I'll talk about anti-affinity, affinity, constant, resources and all little bit later. I don't want to confuse you with everything, but overall, this is your master. So master has a 4 component: API server, cluster store, controller manager, and scheduler, and that we call it together as a master. Make sense, guys?
Does indeed, Rajesh. Just a quick question.
Yeah.
Well, API server, you can call the, well, I would imagine it as a gatekeeper, right? A request comes from outside to API server, and API server then is being looked at by scheduler. So whatever is the request, scheduler put the request to the nodes, right? To the worker nodes.
Yeah.
Understandable.
Yeah.
So here in this picture, I can see that API server also communicates with the controller manager, right?
Yes.
So
Yes. Yeah.
so what happens here in this part when API server talks to controller manager or vice versa?
So controller manager has a multiple controller. Each controller keep monitoring one thing and keep reporting to API server. Based on the reports received from the controller manager, API server check, okay, this matching is there or not, cluster store. I'll talk about this flow little bit later, but it will match or not. Based on that, if API server believe, okay, there's a mismatch in the cluster store and the controller which is sending a data to me, there's a mismatch. So you have to match at any cost whatever you have in the cluster store. So it will instruct the scheduler, go and do the changes in the worker. How? Just give me 5 more minutes, I'll explain it to you.
All right, okay, thank you.
Yeah. So now the question is, let's conclude the master. I hope you have understood that the job of it. Let's conclude. So here in the master control plane components, we have API server, cluster store, scheduler, controller manager. So what is the API server? It is a central for every cluster. It is a simple, restful, and it updates the etcd. You know the cluster store. Now what is a cluster store? It stores the persistent state of the configuration of the cluster, stored in the key and value format, powered by etcd, and it is watchable. Watchable means anyone can query and get the information from that. Scheduler watches API server. Again, scheduler schedule the pods based upon the request from API server. Has a resource constraints and respect the constraints. What is this 2-line resources and respects the constraints? I'll talk about a little bit later. Controller manager has a multiple controller. Each controllers run the loop. It has a life cycle functions, and manages desired state, watches and update the API servers. Look at this. It watches and update the API server, and it has a replica set. What is a replica set? Not now. We'll come back to that. So overall, this is the master control plane component. So now look at this architecture one more time. Here it's a little bit broader. Look at this here. How it's interact. Look at this. Here, human has a laptop, and in the laptop, what you have? There is your utility. What utility you will have? kubectl. Understand that, guys? Human will have a laptop that we call it workstation. So your laptop is a workstation. In your workstation, in your laptop, what you have? Kubectl. Using kubectl, you write a JSON file. JSON file is sent to where? API server. API server stored in the cluster store. Cluster store. Now controller will check the entire endpoints and update the API server saying that, okay, this is what I found out in the my cluster. API server will match the information stored in the cluster stored and what is reported by controller. If it is matching, superb. If it is not matching, desire is not met. So what will happen? API server will instruct the scheduler, boss, you go and do the changes. What changes? Schedule some pods. In where? Nodes. What is a pod? I did not discuss, but one thing we know that pod has a container, right? So we know that. So scheduler will schedule a work to the pod. It has affinity and anti-affinity. That means scheduler may schedule any pod, any node, or it may schedule at some specific node. If it is loving some node, that's called affinity. If it is generally assigning on the random basis, depends on the resource availability, that's called anti-affinity, which is the default functionality. So this is the overall. So now you got to know overall how this master interacts with and help you to manage the desired state. Understand that?
Yeah, I have a doubt here. So what is the mismatch that you're talking about, which is being checked from the controller?
That's the question. I'm coming back. Just give me some more time on this. Yeah. What is the mismatch I'm talking about? Is mismatch which you have in JSON file. What is in JSON file? We need to know. Just give me some more time. Okay.
Sure. Yeah.
Now look at this here. Let's know about the minions. This is a very interesting topic. Let's know about the minions. Okay. So now, before that, I think I should clear this point. You ask a valid question and I should clear these inputs. See here. Human wants to create a 20 container of Apache, Nginx, and 20 container of MySQL. So altogether 40. Now you know that container is inside a pod. So basically, in simple way in Kubernetes, I'm not explaining you too much right now, but here in a JSON file, you will write, I need 20 pod of Nginx. Think about it. You need a 20 pod of Nginx, 20 pod of MySQL. You wrote in the JSON file. How you write? I'll teach you very easy. Through kubectl from your workstation, you send that instruction to the API server. What you need? 20 plus 20 pod. Each pod has a one container. Consider, assume that. Now this is your desire. Okay, it's been sent to API server, and API server will do what? Store in the cluster store. Now controller will keep checking and inform the API server, boss, I did not find any pod here in my cluster. So here API server will check. I have a request for 40 pod, two different kind of pod, 2020. Controllers is reporting 0 pod. That means how many pods need to be created? 40 pod. Of what? This. So what API server will do? Send the instruction to scheduler, which scheduler is been waiting for the instruction. The moment API server will send the instruction to scheduler will schedule the work to the node, saying that, okay, you create 5, you create 5, you create 5. Let's say if it is a 8 node, so 5 each, or if it is a 2 nodes, 20 each, like that. No affinity. So did you understand that how it works like that?
Yeah, but in case, say, for example, if there is a match saying there are already 20 pods, or like 20 pods having each two containers, so totally 40 things. So we already have the resources, and then there is a perfect match. In that case, what would be the work of the scheduler then?
Nothing. Everyone is happy about that. Nothing, because scheduler will act only if it get response from the request from the API server, and API server only raise a request if cluster stored the information what you have, and then controller the information which is sending is mismatched.
So scheduler is invoked only in the case of, if there is a mismatch to initialize the requested number of pods, the resources, right?
Yeah,
Okay.
yeah.
Okay.
Scheduler watches the API server for new pods.
So it's a declarative, basically like Terraform.
Sir, there's a noise actually from you. Huh. So scheduler watches the API server for new pod, assign work to the node. So based upon the request from API server, assign the work to the node. Did you understand this?
Yeah, Rajesh.
Yeah.
One more thing. Yeah.
Okay, guys.
Already,
Now let's.
if already ports are deployment, already ports are exist. In that time, I already 20 MySQL ports are exist. I want to deploy 20 more ports into the like containers into the that ports only. In that time, how API server will work?
Yeah, same function. See, human said I need 20 more. So here API server will store that 20 additional in the cluster stored. Controller will send, you have 40 only, not a 60. You have 40 only. Now API server will read it. Okay, I have a request for 60, but here I have getting the report from the controller 40. That means 20 need to be created. So it will send the request to the scheduler to create a 20 of this type. So scheduler will send the work to the node, create 5, 5, 10, 10, whatever it is a combination of.
Means I cannot reuse the previous 20 ports for the deploying the new NGX container in that ports. Can I reuse the ports for the?
It's like this. Think about it. Okay, it's like this. I think you missed that one of the story of mine. Remember here. Think about it. You are in a production. You are in a cattle business. Your job is to deliver 1,000 liters of milk every day. If it is 999, who will be responsible? You. If it is a 1001, who will be responsible? You. At any cost, desire is 1,000. At any cost, it has to match. Now the question is how Kubernetes will run 1,000 instance of your application. How they are managing? With the help of scheduler, API server, controller, and cluster store. Are you understanding this? Are able to visualize this? This is all about the number of instances which you are trying to run. At any cost, it will be delivered for you. You don't have to worry about it. You just say, I need a 50 and forget about it. You go to sleep. Tomorrow you say, I need a 60. They will create for you, not you will do anything. Just you say desire. Just you perform a desire. Are you getting my points?
Yeah, I will say it.
Okay, guys. So this is the worker. So guys, it's a very important topic, right? Worker. So here, nodes, aka minions, aka Kubernetes worker. So we call it nodes also. We call it Kubernetes worker also, who's really doing the work, and we call it minions also. So guys, how many of you have seen this movie Minions? How many of you? How many of you have seen the Minions movie?
I think all of us would have.
Okay. So if you have not watched this movie, please watch it. This is a wonderful movie. And let me tell you something similar we have here also. Story. Okay. It's completely Minions story. There is one question from Varun Sharma. Can we put our own custom controller as well? Yes, why not? We have our own custom controller. We have to write a CRDs, custom resource definition, and then we can write our own custom controller for our own applications, not controller for the something which is already available in a Kubernetes, the resources, because those resources are already having controller. If you have your own product which you want to control something, that means let's say you want the 3 Nginx only all the time, so something like that. So you can create your own custom controller, CRDs, and stuff like that. So we'll discuss on this. This is the part of discussion. Okay. So guys, I think I'll wrap it up. I'll not go into the minions right now. If you have any other questions also, please ask me, and then we'll discuss on that. Any other questions which you have?
Just a little clarification from your conversation. I concluded that, well, now you're going to talk about the worker nodes or the minions. The worker nodes, I believe they've got their controllers as well. And the communication happens.
No. They don't have any controller as such, but they do have an agent, which I'll talk about it in some time.
All right, okay.
Yeah. So the task for the day. What is the task for the day? I should give it to you. So there's a 2 tasks actually I should give it to you. First one, please deep dive into the containers. Okay, deep dive into the containers. First task. Second task, I would like you to watch Minions movie. Okay, you find in the Prime and or maybe Netflix and something like that. So please watch this movie, and then we'll discuss about the Minions, Akka nodes, Akka worker in the next session. Okay. So as I said, we'll have a few more sessions. Let's say altogether 5 sessions on the understanding the world of Kubernetes, how it works and all. And then after that, we'll get into the demo and lab and demo and.
Excuse me. Yeah, I just have a question. Quick question. I just have a rudimentary basic knowledge about containers.
Thanks for watching. To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.